everyone. Thank you for taking the time and joining us for today's session, The Joy of Testing in Production, with expert guest speaker, Amber Race. Amber is a very busy person, so I am glad that she agreed to allocate some of her very precious time to do this session with us. As you all know, Amber is a senior software development engineer and test at Big Fish Games. But before we officially kick off, I want to take a moment and tell you 5 things about our speaker that you probably don't know. Number 1, Amber majored in Asian studies, lived and taught English in Japan, and speaks Japanese. She also traveled throughout Asia and Europe, only accidentally finding her way to software testing, which is our game. Number 2, before Big Fish Games, Amber worked at Microsoft and has 20 years of testing experience that spans everything from manual application testing to tools development to writing automation frameworks for web services. Number 3, Amber has worked on a wide variety of products and written automation in C#, C++, Python, and Java, just to name a few. 4, she currently specializes in test automation and performance testing for high-volume backend services that support iOS and Android games. 5, Amber is a sought-after speaker, writer, and lecturer. She presented at many international conferences such as STPCon, Agile Testing Days, Star East and Star West, CodeMesh, and Eurotest. She often writes articles about testing and test automation at various publications, and she was the second instructor after Angie Jones to have a course on Test Automation University about API testing. And a bonus 6-point karaoke is her thing, including songs in Japanese. So if you are not already, I strongly recommend following her on Twitter at Amber Tests. And if you're going to Test Bash Brighton next week, you can catch her and Angie Jones there. So without any further ado, I think it's best to let the expert speak. So Amber, the stage is yours.
Hi, thank you for that great introduction, Addie, and thank you for hosting me today. So let me just, there we go. So today I'm talking about the joy of testing in production, and it's a pretty hot topic these days, and it's really a useful skill for any tester. So this is the story of my own journey to becoming comfortable with testing in production. So there we go. So what this story revolves around is I work at a game company. I do not test the games themselves, which is a very important distinction. What my team is in charge of is the services that are behind the games. So all the activity that is saving your progress, that allows you to gift with friends, if there's any chat, there's a lot of different things that are happening behind the scenes when you're playing a game that is by the backend services, and that's what my team is in charge of. And we had a particular service that was in production since 2014, so getting pretty old, but yet one of our most popular games was using it. So it was a very important service that is helping one of our top 5 games. And it had a very weird interface, so it wasn't using a standard sort of JSON or that kind of SOAP interface or anything like that. It's using BSON actually, so it didn't work with any of the tools that are out there on the market. It was meant to support multiple games, and it had a lot of different APIs. So we have this very important service that was out there. But the problem is we didn't know really what was happening with the service. We have a lot of functional tests that are running as part of the build. So we knew that the basics were working, and we knew that the APIs were doing what we thought they should do, but we didn't know, first of all, how exactly were the APIs being used in production. We didn't know how often they were failing. We didn't know what the performance values of these calls were, and because we didn't know all of these things, we would sometimes get issues where there would be an outage and we wouldn't know what was happening. It was just all of a sudden all the requests are backed up and we didn't really have any idea why. So these were problems that were going on, and it's a problem when it's a really important game. So what was the problem? even though we were testing before we went into production and we had a good set of tools for that, we didn't really know, once we were putting it out there in the world, it was sort of, that's, there's sort of a traditional view that once you put your stuff out in the world, you're done. But of course you're not done, because now is the time when everybody starts to use it. It's really just the beginning of your work is when you're releasing to production. So when I started in the business, and for a long time, there was an idea that testing in production was bad. Like, if you've seen the meme, I don't always test my code, but when I do it in production, as if that's a bad thing. And it can be a bad thing if you're not doing a lot of testing beforehand. I mean, you don't want to just throw some code together and just throw it out into the world without testing at all. But on the other hand, there's a lot of stuff that's happening in production that you can't replicate in your office or on your laptop or in a lab or whatever. So the fact is, you're already testing in production. It's just that if you're not testing in production, your customers are testing in production. Your very important users or the people that are playing your games, they're the ones that are testing it. So this idea that testing doesn't happen in production, every time a user opens your application, every time a customer goes onto your web page, they're testing whether your application is going to work or not. And of course, I mean, we already think of A/B testing as some sort of purposeful production thing, but there's so much more that's going on. So instead of thinking that testing in production isn't something that you should be doing, you should be thinking that it's something that's already happening every moment your application is being used. So the problem with testing in production, or with not testing in production, is that it assumes that you're going to find all the bugs before you release. And if anybody's ever tested anything or had any experience releasing anything, you know that it's pretty much impossible to find every single bug. There's almost always going to be something that gets away from you, some scenario you didn't think of, some configuration that you didn't expect, or that you couldn't possibly replicate in your lab. So what are some problems with sandbox testing? People are thinking, well, I have a sandbox to test in and that should be good enough. But how many different client combinations are there? How many different browsers are there? How many different devices? I counted up on one of our devices and we had just, in a certain snapshot of time, 50 different Android devices, 45 different iOS devices, like the combination of the device itself and the iOS version. So there's like 80, 90, 100 different kinds of devices alone. And that's not even considering all the network conditions. People are playing on a fast Wi-Fi network, or they're on 3G, or they're on 4G, or they have some spotty connection that's in and out. There's so many different versions, so many different connections, router issues. It's just, you cannot possibly cover all the client combinations in a sandbox. And so then there's issues with your test environment. Does it match production? Do you have the same memory on your test boxes that you have on your production boxes? For a long time, we were having issues where it's like, we're supposed to be testing the performance, but instead of testing on a production box, which is hooked to its own database, which has two replicas that are happening in our test environment, we have one box that's hooked up to a database that's shared by 30 other services and doesn't have any replication. So this is not, you're not testing the same thing when you test that. Same with the CPU. You might have a very powerful host box out in production, whereas you might have a VM in your test environment. And of course, the database configuration. If you have full replication, not full replication, just having a shared host, all of these things are differences between a sandbox test environment and the actual production environment. And even if you're able to put out, if you have everything Dockerized and you're able to replicate your production environment in the cloud, is something that more people are doing these days. But even then, even if you have your environment in the cloud, does your test user base match production? For example, in the case of the service we were working on, there's a constant load happening of 250,000 players every day playing our game. That's always happening in the background, and we can't replicate that in a test environment. So, does your test user base match production? No, it doesn't. You don't have the same amount of traffic. You probably don't have the same data. It's just not the same. So here's another way to think of it. When you have an application and you're ready to go take it to the club, let it show its stuff, you test all the happy paths, regression, boundary cases, so you got the basics covered. And that's fine, but maybe you want to go a little further. You have all your unit tests, you have continuous build, you have performance and load testing, security test pass, you're just moonwalking all over the place. So then you think, yes, we are ready. We're going to the club. We are going to just slay everybody, and it's going to be wonderful. But then you go to the club, which is production. You go out into the real world, and instead of a nice air-conditioned club where everybody's watching you on the stage, you get this. This is the real world. It's a giant mosh pit of users doing all kinds of combinations, all kinds of configurations, things you would never ever think of. That's what's happening in the real world. And that's what we need to find out when we're looking at our things in production. So how does monitoring in production help you? So what you want to do is you want to monitor your areas of interest. You decide what you want to look at. You can just start with one thing, like what are the API usage patterns? You observe what's happening and you test around those observations. So what we did first, we just set up a counter. How many times is each of these APIs being used out in the real world by actual people playing our games? And then we could see, oh, these are the top 10 APIs. And look, it turns out we don't have a full set of functional tests for this particular API. So now we need to test around that. So just by observing what's really happening, you can prioritize your testing. You increase your knowledge of the software. And then once you have that information, you can add more monitoring around what's going on. So for example, if you have an authentication solution and that is calling some sort of third-party service, you might start by looking at how long does authentication take, and then you might add more monitoring to decide, well, how much of that is my service, how much of that is the third-party service. So this is what I'm talking about when you decide with something small at first, and then you observe, you test, you increase, and then you can build on that. So what are some common monitoring tools? So something, the elk stack is something that's very popular. You basically have things that are based on your logs, or that's collecting information in a database. So for logs, you have Splunk is a commercial tool. The elk stack is very popular. So these are going to take the logs that you have, process them in a way that you can then access the information that's happening in production. Of course, you have to have your log formatted nicely for these things to work. Database, you have Graphite, you have StatsD, you have InfluxCB. So this is where you're instrumenting the code, and I'll show you this in a little bit. This is where you're instrumenting the code, and then it's sort of sending these statistics off to another database to be accessed. And then various displays, you have Grafana, Kibana. These are some options for displaying the code. And I should note that something like StatsD, it's a very small package. This is a daemon that runs in the background, and you feed it a stat, like just a few numbers, and it sends it off. So these are very common monitoring tools. Excuse me. So what we ended up going with was a combination of Graphite and Grafana. So this is what Grafana looks like. And it's very pretty to look at, which is nice. And it's has a lot of options for creating different This is sort of looking at what the APIs we're using, how, every minute, how many times is each API being used, requests per second, I should say. So we have a peak of 250 requests per second for this particular API. And this is just one example of what you can do with Graphite and Grafana. And so why did we do this particular solution? So first of all, Ops was already using Graphite. This is how a lot of these things work. You find out, oh, I want to use something. Always ask the Ops team what they're already using, or ask other people on your team, what are they already using? There's no reason to reinvent the wheel if somebody's already got wheels all over the place. So Ops was already had Graphite in place, so it was easy to plug into it. In our case, instrumenting the code was easier than fixing the logs. And because the Graphite has the query language, there's a lot of flexibility. In Grafana, you can do the templating, and it's pretty to look at. So let's look at some examples of that, and hopefully this is all going to work as I exit this. And let's look at the code. So this is a service. This is a service that's using Drakh Wizard. And just as an example, I have the, so here I have just having it report to the console and having it report to Grafana. Wait, sorry, that's the wrong YAML file. Here we go. This is the one. All right. Oh, it's not the one. So this sort of thing, you have the appenders, and it's pretty easy to set up in Graphite. And you have, for each of your resource, you just need to say it's timed, so we're going to do a timer, it's metered, and we're going to check exceptions as well. So this is all comes for free with Drakh Wizard, just as an example of a Java service here. Another example, let's open that up again. There we go. So, or you could, in our service, because it wasn't Drakh Wizard, we sort of had our own method in here that we put in using Graphite, a Graphite plugin for Java. Graphite works with Java, it works with JavaScript, it works with Python, Ruby, pretty much any language that you could write a service in, Graphite has a plugin that works with it. So in this case, we're getting the request count, fail replies, response times, exceptions, and then we're registering the metrics. So in this initial solution, the service itself was collecting its own metrics and sending it out. And then this is sort of a closer look at what I was showing with the Drakh Wizard. So each of these is folder, and then what does it look like when you get to Graphite? Oh, here. Sorry about that. So then it's stored in Graphite, and you can look at it. It's already done the work of deciding the M1 rate. So the M1 rate, whoops, sorry about that. If you look at these, we have the M1 rate. So that's, we're looking at requests per second, averaged over 1 minute, averaged over 5 minutes, or averaged over 15 minutes, or just the mean rate overall. So these are things that come for free with these Graphite plugins. You don't have to calculate it yourself. So that is very handy with Graphite. And then this is what it looks like in Grafana. So you can have it look very pretty here with the player requests all separated by the APIs. So let's take a look at Graphite. So I have Graphite here. I ran a test earlier. And we have here under player, there's a Graphite Docker image. You can go out to Docker, get the Graphite image, run it, and it will start working pretty. You don't have to do a whole lot of configuration. So that's another thing that makes Graphite good. So I can click on these, Here I have the timer data. This all comes for free with the Graphite plugin. It shows me again the M1, M5. I have what's the median performance. Let's clear all of this stuff. We're just going to remove all of this. So for example, the P50 rate or the P75, yeah, except let's go back. This is going to be for the past hour. There we go. So this is where the action happened. So we can see the P50, obviously the P75 is going to be higher. So with P50, that's 50% of the calls were above this level and 50% were below. And here, this one, the P75, 75% of the calls were below this level and 25% above. So this is when you hear people talking about 2 nines, 3 nines, this is what they're talking about. Here we go to 95%. So now we're starting to get to the interesting data. So 5% of the calls were more than 400 milliseconds. I should say that these were calls happening on my laptop, so anything that's 400 milliseconds is quite slow for something that's all happening locally. And we can add more, 98 and 99. Now some of these, almost a second to do this get player, and then P999. So now this is the worst of the worst. 1 in 1,000 calls were up here. You might think, oh, 1 in 1,000, that's not so bad. Well, if you have 1 million people doing something every day, then that's 1,000 people that could hit this problem. If you have 1 million people that are hitting this API 10 times in a session, then it could happen. It's no longer 1 in 1,000 chance. Now it's a 1 in 100 chance. And then if this is something that's more likely to be hit the longer people are playing, so the people that are most dedicated might be most likely to get the worst results, if that makes sense. So just because something is, 1 in 1,000, you need to think about what that actually means, because your most important customers are also the ones who are using these APIs most and are most likely to have these bad experiences, these 1 in 1,000 experiences. So that's Graphite. And, these graphs are okay. I mean, they're not bad, but there's even more that you can do. And I'm hoping this is going to work. It was not working earlier, but we'll give it a try. Let's go to Gryphon. Oh, okay. Well, I wanted to show you Gryphon on my machine, but let's start it up. And fingers crossed, everybody. Yes, we want to allow. All right. No! All right. Unfortunately, I won't be able to show you Gryphon right here on my screen. Maybe I'll do a blog post or something about it later, because Gryphon is a really cool tool. But I can still show you some of the Graphite things that are available. So if we go to the graph data, there's a lot of functions you can combine, sums, min, max, lots of stats things, lots of way to sort of group. So you can group by APIs, you can group by host machine, you can group by the game or the page that it's coming from. There's, maximum above, maximum below. So there's a lot of different ways that you can look at your data that's available through Graphite and in Gryphon. So that's just a quick look at that. And let's see. So what do we track? I've talked about various things you could track. The things that we decided to track, which worked for us, of course, the specific APIs. We looked at the request count, the failures, and the response time. And We also decided to look at Memcache usage. We were using Memcache solutions, so looking at the hits and the failed gets and how many times we were deleting things. That was something we decided to track. The thread counts per the machine. Exceptions is a really important one to track. What kind of exceptions are being thrown and how often are there peaks? We added tracking for the third-party response time because we did have an issue where we were depending on a third-party service that maybe wasn't as reliable as we would hope. And of course, the system stats. Some of this ops was already tracking, but just putting it on the same page with the API-specific stuff was very helpful in seeing if there was any trends with this particular API usage spiking, and does this also correlate with the memory spiking or things like that. And of course, database statistics. This is another thing that in our case, the DBAs had some graphs, but just putting all the graphs together in one place is really helpful for seeing correlations between perhaps you have an API that's doing more reads than you expected or more writes, etc. So just being able to see everything together was really helpful for understanding our service. Okay, so what did we find? Because that's the point. The point is that things weren't going great, so we added monitoring, and hopefully we're going to find out ways we can improve our system. So something we found was poor API usage. We would have calls that the game was making that failed every time. They just failed because the game was, maybe it was an older client, or we had changed the API and they had never changed or something. It was an invalid call. So that's a waste of time for everybody. It's a waste of time for our service. It's a waste of time for the client. Obviously, this call was not necessary because nobody had complained about it before. So having them remove those calls, it's saving traffic on our site, it's saving network traffic for the player, it's a savings for everybody to get rid of these things or to fix them. We also had issues with save APIs that were called too frequently. For example, once we started really digging in, we could see that there were games where it's like a Mahjong game where you're putting tiles out, you're matching tiles, and every time it would make a match, it would save the data at that point instead of saving at the end of the level. So that is way more writes on the database than it's necessary. So that's the sort of thing that was exposed right away once we started tracking that. Memcache issues. We did have an API that was trying to save a null value, and of course that fails. You can't save a null in Memcache, and why would you want to? So we were putting a lot of extra traffic on our Memcache servers by having all of these, thousands of invalid Memcache sets every minute. So a quick fix to the service saved that sort of traffic. So a lot of this is sort of picking out things where you can save the load, you can save the traffic, and make it everything smoother. So database overuse, I talked about this before, where the API calls are saving too much data, and that could cause some very serious issues on the database. And we had another instance where the game was calling the database every 30 seconds. This client was like, get me the items for this user, get me the items for this user, get me the items for this user. And it turned out 95% of the time, the user had no items because the items in question were only given out by customer service. So we're making all of these database requests and there's most of the time no data at all. So we were able to do some, put some caching in place where it's like once they didn't have, we knew they didn't have data, we didn't hit the database anymore. And that customer service would then clear that cache and then we would know. The point is that that alone caused a 30% drop in particular load on the database, was fixing that call. 10%, but still 10% is important. Slow requests. So this was a really big issue for our service where we were having problems with when our third-party auth provider was slow, they would have a spike. Maybe, everything is going along, taking 200 milliseconds, and then all of a sudden it takes 5 seconds for them to return. And by doing the monitoring, we were able to correlate our issues with this particular spiking issue. So that turned out to be very helpful in then figuring out how to mitigate those problems and work around times when our providers weren't as performant as we would like. And then thread config issues, it turned out a lot of the boxes were using the default thread configuration of 16 threads, which we could be getting a lot more out of each host by upping that to 32. So this was something that we also monitor. So that's the sort of things we found. But you have a dashboard and you really need to maintain that dashboard. So just because you have a dashboard and you find issues, it's more of it's a constant thing that you have to look at. So for example, we found the Memcache issues, but then the Memcache, that was sort of, okay, the Memcache graphing did its work. Maybe we don't need to have this stuff on the dashboard anymore because it takes up a lot of space. So consolidate as much as possible. I already talked about having your APIs with your system health, with your database health. If you can have that in one place to look at, that makes it easier to diagnose things. But the other thing to look at is make sure that the graphing solution, that the monitoring solution you have isn't adding too much overhead. I mentioned how we originally started with Graphite, which was collecting the data on the service. So the service itself had a class which was doing this data aggregation and sending it off. But that was actually itself creating load within the service. So we did end up switching it out for StatsD, which has its is a lighter weight aggregation service. So you want to collect the data, but you don't want to bring down your whole service with data collection issues. I was just reading about something last night where somebody had an issue where their monitoring was doing a lot of changing longs into dates, and it was making their traffic extra heavy. So just make sure that your solution isn't adding too much overhead. And then always reevaluate your metrics. Are you really collecting the stuff that you want to see? And are your metrics providing value? So that's monitoring. If you are on Twitter or sort of involved in this testing and production space, you've probably heard about observability. This is the big buzzword in the last year that is sort of the new hotness when it comes to testing issues, I would say. And the difference between monitoring and observability is that with observability, with monitoring, you're just getting sort of an average, like this is the average over 1 minute, but you don't know exactly what went into that average when you're looking at the graph. Whereas when you have something that's completely observable, you can look at specific calls that are happening within that moment of high performance issues or whatever. So being able to observe to trace a call all the way from when it enters your service, when it goes out to the cache, when it goes to the database, it comes back, being able to see everything that's happening. The more you can see, the more you can observe, the better it is. So that's another difference between classic monitoring and observability. I mentioned Charity Majors here. She's the CEO of honeycomb.io, which I do not work for or anything, but she's a very interesting follow if you're interested in these issues, Mipsy Tipsy. And so that's, if you want to look into observability, that's a good place to start. So just to talk a little more about this. So this is kind of a typical metrics dashboard. This is these are little screenshots from an actual Stackdriver dashboard. That is the Google Cloud graphing monitoring solution. We have this stuff that's being handled by Firebase, and we have Stackdriver monitors, which is, again, pretty and nice, but then you see something like this. What is happening here? I don't know. Something happened there, but all we have is the lines that show this 5-minute interval rate. So within this 5 minutes, something happened, but we don't have a way to drill in and find out what. And the time had already passed by when you see this. So that's sort of the downfall of the typical metrics dashboard, is that it's only telling you things that happened in aggregate for the most part. Whereas when you have all of the data, like for example in Honeycomb, then you can see the aggregate, but then you can also drill down. So let me just show you a little closer what I mean by that. And where am I? Here. It's a different window. All right. So there's the graph. And then we can look at the raw data that went into this graph. Hello. So here you can see that I can look at everything. And, you know, I can drill into what are these ones that are taking a really long time? Or, you know, is there a particular address that's causing problems? The point is you can get very detailed in looking at what exactly is happening. So for example, in this particular situation, by using this observability instead of just the aggregate, I was able to find out that certain clients were actually making many, many more calls into this system than we expected. You know, 50 to 100 in a go, whereas we expected 10. So from a single client. So being able to look at that sort of solution, really digging in, that's kind of the difference between something that's just being monitored and something where you can really observe. So if observability is so great, why bother with traditional monitoring? So this is one of Charity's slides that I put in here. Well, first of all, you know, the monitoring tools are easily available. They're open source. Your ops team might already have them in place. And the dashboards is, if you don't have anything to start with, just getting a dashboard of one thing is going to be helpful as opposed to having nothing. And I think with the monitoring tools, you can still observe what's going on and you can still inform your testing with traditional monitoring tools. And being able to see something is better than being able to see nothing. I say, wait a minute. This is supposed to be testing in production. All we've talked about so far is debugging issues. So what about testing? All right, testing. Here we go. Performance testing. Once you have things set up in production, you can test new APIs in production. This is, in my experience, the #1 best thing about testing in production is doing performance testing in production. So you can, before your clients are updated to use a new API, you can put it out on your production service. You can run a load test on that particular API while you have all the background noise going. And you don't have to guess, well, I ran it on this stage environment, so if you multiply that by 3 times, it should be equivalent to production. If anybody's done that kind of thinking, you don't need to do that when you're doing performance testing. And it has the real background load. So as an example, we had a new API for this particular service, and I did test it in production, and with a very short test, we could see that it increased the CPU by 30%, this one API. So then we immediately knew, because it was production, we didn't have to guess, well, is it 30% because the CPU is bad? Is it 30% because the database is overloaded with other services? No, we knew, because I'd run the test in production, that there was an issue with this particular API, and indeed there were. So being able to do these performance testing in the real environment is invaluable. Then feature testing. So if you have features that are flagged at a config level, so you just need to redo the configuration to toggle features on and off, then you can update your configuration on a single box in production and just see what happens on that one box. So again, you have the real hardware, you have the real traffic, you have real user experiences happening just on that one box. And if it's something you can turn on and off easily, then that makes for a very useful test. And chaos testing, most people have probably heard of Chaos Monkey out of Netflix. This is the sort of testing that, again, you can really only do in production. This is where you use, like, what happens if this particular host goes down? What happens if this particular database is offline? These sorts of network outage conditions, once again, with the production environment, seeing if your flows are working the way they want to. You want to test these in a place where you have control rather than letting the real chaos take over and then you're up at midnight trying to figure out what's going on. So those are just some examples of how you can test in production. And really the monitoring, the observing, the testing, it all goes together. So if you think about the, sort of a typical situation where you first do exploratory testing and you're sort of observing what happens, and then once you know what happens, you put a monitor in place to make sure it keeps happening like that. So I have a tweet here from Martin that sort of sums this up, where monitoring is sort of the things you know to look for, but observing, you can look for new things to look for. And you can do this even without a so-called observability solution. Just sort of taking the information and sort of pushing it is really important for baking more quality into your services and understanding your services and applications better. And this is sort of, there's a lot of fear when you're doing things in production. Oh my God, I'm going to break everything and it's terrible. But the point is not to break things, is to find out where things are broken. That's why we're doing the monitoring in production. That's why we're doing this testing, is we want to see what's happening with our actual users and where their issues actually are, and hopefully alleviate them. So we're not breaking stuff, we're just letting people know that they're broken. It's an important difference. And most importantly, explore without fear with your proper production monitoring. So for more information, I have this slide. I'll just leave it up here for a moment. So these are some various places you can get more information on monitoring tools that I've talked about. If you want to contact me, and here's my information. I also have a course on Applitools Test Automation U, which is for API testing. If you haven't taken that course, please do. And that is the end of my presentation. So I'd be happy to answer any questions that people have. And thank you for listening to me. And I'll put this back on the more information while we're talking.
So yeah, we do have a lot of questions. As expected.
Yes.
Yeah, so I'm going to ease into it. We're going from the lighter ones to the heavier ones at the end.
Oh, okay.
A question about slide 15.
Sure.
How do we integrate the Grafana report with performance automation frameworks?
So, oops, sorry. JMeter actually has a Graphite plugin that you can use to I'm just talking about JMeter specifically, and because that's the tool I'm most familiar with. But here, I'm just gonna make this a little smaller so I can show you Java. And so in the plugins manager, you actually can do a Graphite plugin, and that will get the information right into there if you're running performance tests. Also, if you're already testing the CPU and the memory and all of that, when you run a test in production, you can see the effect of that happening. Just like if you have greater load happening from the outside, your performance test is going to do the same thing. Does that make sense? Hopefully that answers the question.
I hope so. Next one, I think it's about the same topic. So slides 12 to 15.
Okay.
How do you correlate your results from TIP with testing in pre-release environments? And is it necessary for turning the data from your monitoring into action items for devs?
I'm sorry, so the question is how to take the data and turn it into actionable items?
Yeah, I think
is that the question?
It was a two-part. So first of all, how do you correlate your results from TIP with testing in pre-release environments?
Okay.
And the second one, how do you make it? How do you take the data from your monitoring into actionable items for your developers?
Right. So I think that the testing and production data is really a whole different thing. It doesn't actually correlate with our test environment data. I mean, we do have play testing that's going on, and that produces some basic idea that we can collect in the same system, but it's just not going to be the same as testing and production. It's really a different class of data where we're looking for more functional issues, just making sure everything is working together. The basic functionality, I think, is handled in the lower environments, whereas when we're looking at the data that's in production, we're looking for stuff that we didn't expect, stuff that we didn't see in the lower environments. So that's the first part of the question. I'm sorry, what was the next part?
How do you take the the data from the monitoring and turn it into action items or actionable items?
So with the graphs, so we have, and I'm disappointed that I wasn't able to show the Grafana, but with the Graphite, you sort of get the idea. We have these dashboards. They're available to everyone. I've just taken screenshots sometimes of the data and saying, look at this. What is going on with this graph? Or send a URL that says to a graph. And when you have a visual representation, it's a lot easier to decide that something's going on. So definitely these dashboards, all this information should be available to the whole team, not just to ops or testing. I hope that answers the question. Yeah.
Okay. About the common monitoring tools slide. Is what is the difference between log and DB based, and when would you use each one?
So the log based is going to, so if you already have logging that's happening on your service, and you're putting that, and you have the log sort of in a structured format, and this is big in the observability world as well, that you have a structured log. So not just a typical date and then some sort of gobbledygook and then the URL, blah, blah. You want to have information in this log like this is the API name, this is how long it took, this is the IP address it came from. So if you have like a JSON blob in your log that's then loaded up into the Elasticsearch or Logstash will take that and turn it into something searchable, then graphable. And Splunk does the same thing. So the point is they're based in the logs. You don't have to necessarily instrument the service itself. It's using the log output. Whereas the DB based doesn't leave a log behind. It just takes this information directly from the service and puts it into a database. It's kind of a NoSQL type of database where it can look it up very quickly. So that's, I mean, we still have the logs, but in our case, the graphs that we're using does not come from the log data. Hopefully that answers the question.
So we had another question asked around the Graphite demo.
Sure.
How much time does it take to set all this up? Did you have a dedicated team member or members to organize, install, and set up these tools?
So we were fortunate in that the ops team had already set up Graphite, but on my own, for the demo, like I said, I was able to go out to Docker, run the Docker image, and it's working from that point. So for an initial setup, it's quite simple. Of course, like all of these things, sort of drilling in and deciding the sampling rate and how long you want to save stuff, it can get very complicated. That's why I definitely recommend talking with your ops team and see if they already have something in place for if they're doing systems monitoring, they might already have something. But I would say that when I was doing this, I was the person who was setting up the dashboards, etc. I took that on as my task as a point person, but it takes more than one person. But for the initial setup, I would say that Graphite is pretty simple, and then hopefully once you have a proof of concept, you can get more people in to host it in a more thorough, robust way.
So the next question, we actually got several questions in the same tone, and so obviously very interesting to people. And it's more of a general question about testing in production. So what people are asking from your experience, how is the dev team acceptance of the idea of testing in production? And if they were not so inclined or so not very accepting, how did you go about convincing them of the benefits?
Okay, well, I'll say that for like the initial monitoring stuff and just sort of tracking what was happening, the dev team was all in on that. They thought it was great, and nobody had a problem with just tracking what's happening. Where I did get pushback, whereas I'm suggesting, hey, here's a load test, let's run it in production. the ops team got a little nervous about that, as you can imagine, because the whole idea is not to bring down production. It's very important to keep it running. So I was able to demonstrate, that I have the test running and that I'm able to stop it right away. Being able to show that you can stop the test and mitigate any potential damage from what your test is doing is really important to getting buy-off. So in the example I gave in the presentation, I sat there, I'm sitting there right over the stop button. When I see things are getting worse, I was able to stop it right away. And so it turned out fine. So once I was able to demonstrate that, then they had more confidence that we could do this kind of testing in production.
So next question is from someone who's already using SEQ and Graylog and asking if you have advice for using those tools since they're already installed.
Okay. I'm actually not familiar with either of those tools, but I think that the principles of gathering the data are similar. That so I don't have any specific advice, unfortunately. Only that the general advice of understanding your metrics, understanding what you're looking for, and sort of slicing up the data in different ways is going to potentially find you more interesting information.
So the next question is, can we use Graphite and test in a test environment with Loadrunner for performance testing? And if yes, how do we do it?
Okay, I think you could do it. I'm not familiar with Loadrunner specifically, if they have but I think that you could probably have either some sort of, if there's a plugin for Graphite or with StatsD that can run sort of as Loadrunner is doing its thing, that which you can do with JMeter, but you could probably do it with Loadrunner as well. Another thing you might want to look at is this is where a log-based solution might come in handy if you have the Loadrunner logs, and then being able to load them up into something like Logstash or Elasticsearch. So
now we're getting to the questions that I get every webinar. I told you we're getting to the heavy stuff at the end.
Heavy stuff. All right.
And actually this is funny because I saw something regarding our next question in your Twitter feed. I think today or yesterday. So ultimate questions: should testers know how to code? And if yes, what are the basic coding skills they're expected to have?
Okay. Well, I mean, if you're looking at my Twitter feed, you know that I do believe the testers should be what I'm calling code literate, which is not necessarily like you can write your own service, but you should be able to read the code that you're testing, understand how it works together, maybe do some simple scripts. For this sort of what I'm talking about in this particular presentation, you don't necessarily need to know how to code. Especially if you're using Drakh Wizard, or the developers can sort of put this instrumentation in. If you can't code, then you're depending on the developers to put the instrumentation in. But I think, the more you know, the better, but you can do this stuff without knowing how to necessarily code. But it is important to understand the services you're testing as much as possible. So I don't know if it answers the question. I'm always going to say that more knowledge is better than less knowledge, but everybody has time constraints, and there's a lot out there to learn. So picking the stuff that's most important is really key. And I think actually something that's important, and something I'm going to be talking about next week, is just knowing about statistics and how different statistics work, and what they can potentially tell you about your service. Even that sort of basic statistics knowledge is really important for testing and production, observing, all that sort of stuff before you even code.
So yes, you actually you mentioned Charity Majors, and yeah, she had a very interesting tweet a few weeks ago, which really resonated with me, because we're talking a lot about technical, and she said that term should not be used to alienate people that don't write the code, because it's currently used by software developers as to define someone that writes the code. And technical can be anyone that's tech savvy, that understands the product, know how it works, knows its USPs, and knows how it creates value for the users.
Exactly.
Yeah, and so I think that at least from the point of view of testers that code, we need to remember that it's a lot, but it's not everything, and you can be technical without actually writing the software.
Exactly.
Yeah.
I just have one more comment on that topic. One of the things that I think separates the test discipline from the development discipline is testers need to have a broader view of the whole system. So whereas the developers might be, a specialist in memory management in C# or whatever, and they have a master's in computer science and they're really good at that. Whereas when you're a tester, you kind of need to know maybe not so much, but about a lot of things. So being technical is not just being able to write code, it's being able to understand the entire system under test, how the pieces work together, and how that ultimately affects the usability and the greatness of your product.
Yeah, I think that's a super important distinction, by the way, and I'm glad that we got to talk about that. And so since we are out of time, I just want to ask one last question that is also important to our audience, and I think it sort of closes this discussion very nicely. And they're asking, you are hiring testers, what skills or experience are you looking for?
When I'm interviewing testers, the number one thing that I look for is being able to ask good questions, and being curious is really the key thing. You can teach somebody how to code very easily for a specific thing, but being able to have the right amount of curiosity, being able to sort of dig in and see where the possible weaknesses, that's the sort of thing I'm looking for when I'm interviewing testers. So I don't expect you to go and write something up on a whiteboard, but I might show you a piece of code and ask you how you would test it, that sort of thing, depending on what kind of test. I'm usually interviewing SDETs, so that's how that goes.
Okay, so first of all, I want to thank everyone that joined us today. I want to tell you that I see all the thank you notes that you are writing to Amber, and I promise that she will get all of those. I will send her all of those thank you notes. It's just this session was for Q&A, so I didn't get to read out all of the.
I'll accept all the praise offline.
Yeah, exactly. But be sure that any note that you write to Amber right now in the questions panel will be sent to her. So again, I want to thank you for all of you for joining our live session, and of course to thank our guest speaker Amber. And before she says goodbye, I just want to remind all of you that yes, the recording will be sent to you by Monday. So don't worry about that.
All right. Well, thank you very much for hosting me. It was a pleasure, and hopefully people got good information out of it. So thank you again.